Hi everyone and welcome back to another lab. In today's lab, we will explore the second scenario for practicing variable length subnet masking. So in our previous video, we discussed how to tackle subnetting for the RFC1918 Class C, which it was fairly simple and straightforward, especially when you use the subnet mask table calculator. Today, I will walk you through how to subnet RFC1918 Class B and show you a trick that will help you do subnetting easily moving forward. So let's start our session by covering the main objective of this lab, and we will follow this by walking you through the topology, the IP address and VLAN tables, and then the lab task. Finally, I will walk you through the configuration steps and the lab solution. So in the RFC 1918 Class B refers to the range of private IP addresses designed for local use within a private network. Specifically, Class B is ranging from 172.16.0.0 to 172.31.255.255. These addresses are reserved for use in internal networks and are not routable over the public internet. They are commonly used by organizations to create their own private networks. And as you can see on the screen, the number of addresses is more than 1 million IP address that is available from that range. Regarding our lab objective, our goal is to gain practical experience in subnetting and variable length subnet masking. We will subnet an IP address space into smaller and more efficient subnets. We will also allocate IP addresses to network segments based on specific requirements such as the number of hosts and departments. We are going to configure routers and switches to support the newly subnetted network, and we are going to verify connectivity between devices within and across subnets. If there are any issues that we might have, then we might need to do some troubleshooting and resolve any issues encountered during the configuration process. And the main objective is to gain hands-on experience with variable length subnet masking and enhance our networking skills. So by completing this lab, participants will develop a solid understanding of VLSM concepts and be better prepared to design and implement subnetted networks in real-world scenario. Regarding the lab topology, you can see that we have used the same topology from our previous video. What we see on the screen here, router 1 and switch 1. Router 1 is connected to switch 1. Router 1 has a loopback interface 100, which mimics the Google DNS server, which is 8.8.8.8. Switch 1 is then connected to multiple departments. We have Fast Ethernet 01 and 02 participates in VLAN 100 and are part of the engineering department, where our Fast Ethernet 03 and 04 participates in human resources department and do resides in VLAN 200, so on and so forth, as you can see on the screen. The link between switch 1 and router 1 will operate as trunk mode, where are the links from switch 1 to all the PCs will be operating as an access mode. Now let's move to the IP address and VLAN tables. And the first table we see on the screen here is the router IP address table. Please take a screenshot as you might want to copy the table across so that you can fill this table yourself. Okay, so much like our last lab, we have the router IP address table where we need to fill in the empty cells, and we will do that once we have read the lab tasks, understood the business requirements, and performed subnetting based on the requirements. So what you see on the screen is self-explanatory. The left column is for the device name. We see the interface ID, which is related to all the interfaces that will be configured in the lab. We will need to fill out the IPv4 address as well as the subnet mask. We then look at the host IP address table, where you can see that we also need to complete the empty cells. We will need to set the IPv4 address as well as the subnet mask per host, and we will also to set the default gateway and the side annotation for each computer. This table is related to switch 1, where we can see each interface resides in which VLAN, and we also can see the mode of each interface that will be needed in this lab for switch 1. So as we discussed earlier when I walked through the topology, the interface gig Ethernet 01 on switch 1, which is connected to router 1, is going to operate as trunk mode, and it will only allow the following VLANs, 100 all the way to 600. Whereas the fast Ethernet 01 all the way to 012, each interface will be participating in different VLAN, and all of these interfaces will operate as an access mode. Now let's move into the lab task, and the first task is building the lab, either virtually or physically. Once you've done that step, you move to the next one, configure each device according to the lab topology. We have switch 1 and router 1 that we would need to rename. We then move to the third step, where on router 1 we would need to create a loopback interface, which is 100, and we are going to assign the IP address 8888 with subnet mask 32. We then move to the fourth step, where we have been asked to perform some documentation, where we need to do and perform some subnetting regarding the following IP address, which is 172.16.0.0/16. And what we need to document is the department, the network address, the broadcast address, the maximum number of hosts, the first host, the last host, and the side annotation. Following the lab task, we can see that the network topology consists of a headquarter and a couple of branches, and the company has the following departments, and each department requires a number of hosts. So we have the engineering departments, which requires 20,000 hosts, whereas the human resources department requires only 1,500 hosts. We have the IT department requires 500 hosts. The production department requires only 10,000 hosts. The finance department requires only 2,500 hosts. Finally, the distribution department requires only 5,000 hosts. So moving to the next requirements, we must assign address block with each department that has the largest number of hosts and ending with the department with the smallest number of hosts. In other words, we would need to sort out these departments based on the department that requires the highest number of hosts, and then the lowest, and then the lowest, and then the lowest, and so on and so forth. Once we've done that, we then move to the next one. And the next one is we have to create the smallest block of IP address possible while allowing sufficient address to encompass all hosts in each department. Then we move to the next step, where we are going to create an IPv4 address table that includes the default gateway, the IPv4 address, and the subnet mask for each computer. And one of the requirements that we have to follow is each odd PC number, for instance, PC1, PC3, PC5, so on and so forth, must use the first usable IP address from the given subnet, and each even PC, for example, PC2, PC4, so on and so forth, will have to assign the second available usable IP address from the given subnet. And then each PC, we will have to use the last usable IP address from the given subnet as the default gateway. And then finally, we are going to assign the last usable host from the given subnet to each sub-interface configured on router 1. Now, once we have configured that step, let's move to the next step, where we are going to create the sub-interfaces on router 1. We can see sub-interface gig Ethernet 001.100, that will be part of the engineering department. And then .200, that will be part of the human resources department, so on and so forth. Once we have completed all the sub-interfaces, we will then need to make sure that the encapsulation type has been set, as well as the VLAN ID. And finally, we need to make sure that the IPv4 address has been assigned on each sub-interface. Next, we are going to log into the switch CLI, and we are going to tackle the port that is connected to router 1, and we are going to make sure that that link is going to be operating as a trunk, and we are going to allow only the VLANs in question. Once we are done that, we move to the next step where we are going to create the VLANs, and we are going to name each VLAN according to the topology and the requirements. And then once we have done that, we are then going to set all the ports to reside in the appropriate VLAN. Once we are finished with this step, we then move to the next one, where we are going to assign IPv4 addresses and subnet mask as well as the default gateway on each PC in the network. And then we are going to verify connectivity between each host with the default gateway as well as the loopback interface 100. Once we are happy with our configurations and testing, we then can save our configurations across all network devices. And at this point, we have reached the end of the lab task. Okay, now that we are ready to go ahead and jump into the configuration steps and lab solution, you will find in the video description I included information related to the lab. So you will have the lab document that also includes the lab solution, and you will also be able to download the packet tracer lab ready to go for you to configure. You will see that I included two different packet tracer files, one that is before the configuration solution and the other one is post the configuration solution. With that being said, it is your chance to pause the video and give it a go yourself. Otherwise, please keep watching. Okay, now I'm going to deviate from the configuration steps by jumping into step 4 and step 5. And once we have solved these steps, I will then go back and cover step 1, step 2, step 3, so on and so forth. Okay, so if you would like to know how you can build this table, please refer back to my previous video, which I've included in the description below as well. So if you are following along from our previous video, I have added the subnet mask section on the left-hand side of the table to show you the octet position and its relationship with the CIDR column. So since we are going to work with /16 subnet mask, we will then need to use the third and the fourth octet of the subnet mask to accommodate each department's requirements. So you can see this is the first octet, this is the second octet, this is the third octet, and this is the fourth octet. So if you would like to take a screenshot of the subnet mask calculator table, please do, because I want you to refer back to it when we go through the lab solution. And with that being said, let's dive into the actual solution of the lab. So the IP address block that is being given to us is 172.16.0.0/16, and we will need to tackle the first department that requires the highest number of hosts. And what you see is the engineering department requires about 20,000 hosts, which is the highest number of hosts that is required. And in order for us to accommodate that number, we will need to use /17. And the reason why we need to use /17 is because this subnet will give us around 32,766 hosts. We will start our network address with 172.16.0.0. However, the subnet mask is going to change and it will be 255.255.128.0. If we were then to take that IP address and then do the subnet for it, so the network address will be 172.16.0.0/17, and the mask is going to be 255.255.128.0. The first usable IP address will be 172.16.0.1. The last usable IP address is 172.16.127.254/17, and the broadcast address is 172.16.127.255. So the question that I have for you, how would you then work out the broadcast address for this network segment that we talked about, which is 172.16.0.0/17? So to answer this is very simple and very straightforward. You just need to follow the pattern and follow the equation. If you fetch a couple of attributes before you tackle the equation, the first attribute that I need you to look at is the maximum number of networks for /17. And you can see the answer to this is 32,768. We also need to look at the maximum number of networks that is available for /24, and you will see the answer to this is 256. So if I go back to my subnet mask calculator, you can see that /17 offers 32,768 networks, and whereas /24 it offers 256 networks. So if we take these two variables, we divide the 32,768 divided by 256 and then subtract 1 from the result of this division, we will get 127. We get the result of this equation, and then we add it to the third octet of the network address. We then take the sum to place it on the third octet of the subnet mask and set the fourth octet with 255. So the final result, it will be 172.16.127.255. To work out the last usable IP address, we just subtract 1 bit of the last octet of this network address. So you will end up having the broadcast address, which is 172.16.127.255/17. And then the last usable IP address will be 172.16.127.254 with /17. Now that we have allocated this subnet to the engineering department, we can then move to the next department. And the next department is the production department, as it requires 10,000 hosts. And we will have to start this time with this IP address, which is 172.16.128.0 as the network address. And in order for us to provide 10,000 hosts, we will need to use /18 this time, because this subnet mask will give us 16,382 available hosts. So that means the network address will be 172.16.128.0, and the subnet mask is going to be /18 or 255.255.192.0. The first usable IP address is very simple, very straightforward. You just need to add 1. And it will be 172.16.128.1 /18 or 255.255.192.0. Again, in order for us to work out the broadcast address, we will have to fetch the attributes first. What is the maximum number for /18? That will be 16,384 networks. And the maximum number of networks for 24 is 256. Now, if we were to divide 16,384 by 256, and then the result of this, we will then subtract 1 from it, it will give us 63. We then take 63, add it to the third octet of the network address, so it will be 63 plus 128. That will give us 191. And then we're going to set the fourth octet with 255. So the broadcast address for this network segment will be 172.16.191.255. The last usable IP address for this segment will be 172.16.191.254. And with that being said, the production department is good to go. So the next department that we need to tackle is the distribution department, and this department requires about 5,000 hosts, and we know that the next available IP address is 172.16.192.0. So we're going to take that, and then we're going to work out what is the subnet mask that we need to use to accommodate 5,000 hosts. And you will see that /19 will give us 8,190 available hosts, and that will be the best candidate for this network segment. So what we will do, we will set the network address to 172.16.192.0/19, and the subnet mask is going to be 255.255.224.0. The first usable IP address, it will be 172.168.192.1, which is the next available IP address from the network address. And again, to work out the broadcast address, we would need to figure out the attributes first. What is the maximum number of networks for /19? And the answer to this is 8,192. And we already know that the maximum number of networks for /24 is 256. Next, what we need to do is divide 8,192 by 256. That will give us 32, and then subtract 1 from 32, and the result will be 31. We then take 31, we add it with the third octet of the network address, which is 192. We add them together, and that will give us 223. And then the last octet, or the fourth octet, we need to set it with 255. And that network address is the broadcast address for this segment. And now, in order for us to figure out the last usable IP address for this segment, it will be 172.168.223.254, one bit less than the broadcast address. So with that being said, let's move into the next department. And the next department is the finance department. And the finance department requires about 2,500 hosts. And the next available IP address is 172.168.224.0. And in order for us to accommodate 2,500 hosts, we would need to use /20, because /20 will give us 4,094 hosts. So again, the network address will be 172.168.224.0 with /20, which is 255.255.240.0. The first usable IP address will be 172.168.224.1 /20. And to work out the broadcast address, again, we fetch the attributes as the first step. And the first one is the maximum networks for /20 is 4,096. And the maximum network for 24 is 256. We divide them and we subtract 1. You will get 15. We then add 15 to 224. That will give us 239. And then we set the fourth octet to 255, and that will give us the broadcast address. So the broadcast address is 172.168.239.255. To work out the last usable IP address, we subtract 1 from 255, so you will get the last usable address will be 172.168.239.254. And this department is complete. We move to the next one, which is the HR department. And the HR department requires 1,500 hosts. And the next available IP address will be 172.168.240.0. And in order for us to accommodate 1,500 hosts, we will need to use /21. And that will give us 2,046 available hosts. So again, the network address, we will start with this IP address. It will be 172.168.240.0, and the subnet mask this time will be 21, which is 255.255.248.0. The first usable IP address will be 172.168.240.1. And then to work out the broadcast address, we just need to look at the maximum number of networks for /21 and divide that by the maximum number of networks for /24, and then subtract 1. That will give us 7. We then take 7, add it to 240, which is the third octet of the network address. And that will give us 247, and then we set the fourth octet to 255, and that will give us the broadcast address for this segment. So the broadcast address will be 172.168.247.255/21. The last usable address will be the broadcast address -1, which is going to be 172.168.247.254/21. Next is the IT department, and this is the last department that we need to subnet. And the next available IP address will be 172.168.248.0. And in order for us to accommodate 500 hosts, we would need to use /23, as this will give us 510 available hosts. So again, the network address will be 172.16.248.0/23, which is 255.255.254.0. And the first usable IP address will be 172.16.248.1/23. Again, to work out the broadcast address, just need to follow the same equation. Figure out the maximum number of networks for /23, which is 512, and divide that by 256 and subtract 1, and that will give us 1, which means we will need to add 248 plus 1, that will give us 249, and then we set the fourth octet to 255, and that will give us the broadcast address. To work out the last usable IP address for this segment, we just subtract 1 from 255, which will give us 254. Next, what we are going to do, we are going to fill the tables with the appropriate IP address per department. And if you would like to take a screenshot of this table, please go ahead, because this is the table that we are going to use. And you can see here the engineering department starts with 172.16.0.0, and we are going to give it /17 to accommodate the number of hosts that it requires, which is about 20,000 hosts. If we then look at the production department, it will start with 172.16.128.0, and we will give it /18, and so on and so forth. Next, we look at the IPv4 address table for router 1, and you can see that we have allocated the last usable IPv4 address per department for each network segment. Again, please take a screenshot if you want, because we are going to use these IPs with the lab configurations. Finally, we look at the IPv4 address table for all hosts. You can see that we have used the first and the second usable IP address per network segment. We have included the default gateway, which is the last usable IPv4 address for the segment in question, and so on and so forth. You can see that we have filled the IPv4 column, as well as the subnet mask, as well as the default gateway and the side annotation. Again, if you want to take a screenshot, because this is the information that we'll be using to tackle the lab configurations, which I'm going to do next. Okay, everyone, and I'm back to my packet tracer lab, and you can see that we have built the lab according to the topology, and we are good to go. So the first step has already been done. Let's move to the next step, where we are going to rename router 1 and switch 1. So I'm going to log into the CLI of each device. And then I'm going to enable mode, config terminal, and then say hostname router 1. Do the same thing for switch 1 as well. Enable mode, then go to config terminal, and then say hostname switch 1. The third task is to create a loopback interface on router 1. So I'm going to say interface loopback 100, and I'm going to set the IPv4 address to 8.8.8.8, and the subnet mask is going to be /32, which is 255.255.255.255. And the third step is complete. Now we have completed step 4 and step 5. So we're going to jump into step 6, where we are going to configure all the sub interfaces for all the departments. So I'm going to exit from here, and I'm going to say interface gig ethernet 0/0/1. And I'm going to set the description for this interface as link to switch 1. And I'm going to enable the interface as well. Now that I have done this, I will then start configuring all the sub interfaces according to the lab requirements. So I'm going to start with .100. We're going to set the description to engineering department, we are going to set the encapsulation .1q, and we're going to set the ID to 100. And then we are going to set the IPv4 address 172.16.127.254. And the subnet mask is going to be 255.255.128.0. I'm going to then move to the next department, which is the Human Resources Department, which resides in VLAN 200. And I am going to create a sub interface, which is gig Ethernet 001.200. And I will set the encapsulation type to .1q, and the ID is going to be 200. And then set the IP address to 172.168.247.254. And the subnet mask is going to be 255.255.248.0. We also need to set the description. So I'm going to say the description, or actually I'll just arrow up multiple times. And that will be the HR department. And then I will hit enter. And now let's move into the IT department, which is .300. And I'm going to set the encapsulation .1q to 300. And then I will set the description. So IT department. And then finally the IPv4 address, which is going to be 172.168.249.254. And the subnet mask is going to be 255.255.254.0. Next, we need to tackle the production department, which is going to be in VLAN 400. So I will set the .1q to 400, and I will set the description to the production department. And then we are going to set the IPv4 address, which is going to be 172.168.191.254, and the subnet mask is 255.255.192.0. Now we can move into the finance department. And the finance department will be associated to interface gig Ethernet 001.500. We set the description. I'm going to say finance department. And we're going to set the encapsulation .1q to 500. And then we're going to set the IPv4 address, which is going to be 172.168.239.254, and the subnet mask is 255.255.240.0. And then finally, we are going to tackle the distribution department, and that is going to be .600, and the encapsulation ID will be 600. We set the description, distribution department, and the IPv4 address is going to be 172.168.223.254. Subnet mask is 255.255.224.0. So if I end maximize the CLI, and then issue show IP interface brief, we can see the gig Ethernet 001 is in the up state, and you can see that we have configured all these sub interfaces with the appropriate IPv4 address. We also can see that we have configured loopback 100, and all the interfaces in question are in the up state. If we then move into step number 7, we would need to log into switch 1 and configure the interface that is connected to router 1, which is gig Ethernet 01. And we need to configure that link to operate as a trunk. And we only allow VLANs 100, 200, 300, 400, 500, and 600. So what we'll do, I'll go to interface gig Ethernet 0/1 config mode, and in here I will set the description. I will say link to router 1. We are going to change the switch port mode to trunk, and we are going to only allow the VLANs in question. So we're going to say switch port trunk allowed VLAN 100, 200, 300, 400, 500, and 600. Now let's do some verification. So I'm going to say show interface gig Ethernet 0/1 switch port, and you can see that the currently is operating as trunk, and the VLANs that are allowed in that trunk are 100, 200, 300, etc., etc. And also the encapsulation is using .1q. We can also use a different command, which is show interfaces trunk, and that will show you that port gig Ethernet 01 only allows these VLANs. Next, let's tackle step number 8, where we are going to configure all the VLANs for each department. So I would need to go to config mode, and then I'm going to say VLAN 100, and I'm going to say name engineering department, and then do the same thing for the other departments as well. Now that I have configured all the VLANs in question, I'll just hit end, and then I would say show VLAN and maximize this. You can see that currently we have the engineering department, which is in VLAN 100, HR department VLAN 200, IT department VLAN 300, so on and so forth. And you can see that we haven't assigned any port for these VLANs or different VLANs. And that's what we'll do next. So I'm going to tackle step number 9 now. I'm going to set all the ports with the appropriate VLAN according to the lab topology. So I'm going to start with fast Ethernet 01. So I'm going to say interface range fast Ethernet 0/1 and 2. I'm going to say description engineering department, and we are going to say switch port mode access, switch port VLAN, switch port access VLAN 100. If I then do the same for the HR department. So we're going to say interface range fast Ethernet 03 and 4. We're going to set the description first. We're going to set it to HR. We're going to set the switch port mode access. And we are going to set the VLAN to 200. Do the same thing for the next department. We're going to say description, IT department. And we're going to say switch port mode access, switch port access VLAN 300. Let's say interface range fast Ethernet 07 and 8. Let's set the description, production department, switch port mode access, switch port access VLAN 400. Next, let's move into the next ports, which are fast Ethernet 09 and 010. Set description, switch port mode access, switch port access VLAN 500. And then finally, the last couple of ports, which are 11 and 12. And these are the part of the distribution department. Distribution. Switch port mode access, switch port access VLAN 600. Now, if I end this and go back to user privilege mode, and from there I can say show VLAN brief, and you can see that we have assigned each port with the appropriate department. Fast Ethernet 01 and Fast Ethernet 02 are part of the VLAN 100, which is part of engineering department. We have Fast Ethernet 03 and 04, part of HR department, and resides in VLAN 200, and so on and so forth. You can see that. Next, we are going to tackle step number 10, where we are going to set the appropriate IP address and subnet mask, as well as the default gateway for each PC. So I'm going to minimize that, and I'm going to minimize this, and I'm going to tackle PC1. Go to desktop IP configuration, and in here I would say 172.16.0.1, and the subnet mask is going to be .128.0, and the default gateway is going to be 172.16.127.254. Go back here and I'll say ipconfig. You can see that we have configured the host accordingly. Let's move to the next one. Next one is going to be 172.16.0.2, and the subnet mask is going to be 255.255.128, and the default gateway is going to be 172.16.127.254. Close this, go there and hit ipconfig, and you can see that we have configured it according to the lab solution. And you can see that we have configured PC2 accordingly. Let's move to the third PC. The IP address is going to be 172.16.240.1. And the subnet mask is going to be 255.255.248.0. And the default gateway is going to be 172.168.247.254. And that completes the configurations. Let's move to PC4. And PC4 will have 172.16.240.2, and the subnet mask is going to be 255.255.248.0, and the default gateway is going to be 172.16.247.254. If I close this, go back there, move to the next one, and PC5 will have 172.16.248.1, and the subnet mask is going to be 255.255.254.0, and the default gateway is going to be 172.16.249.254. Let's move into the next PC. And PC6 will have 172.16.248.2, and the subnet mask is 255.255.254.0, and the default gateway is 172.16.249.254. And that is complete. Move to PC7. Let's go to IP configurations. And PC7 will have 172.16.128.1, and the subnet mask is 255.255.192.0, and the default gateway is 172.16.191.254. And if I close this and go to the CLI and issue IP config, 7 is complete. And let's tackle PC8. PC8 will have 172.16.128.2. The subnet mask is 255.255.192.0, and the default gateway is going to be 172.16.191.254. Go back here and issue ipconfig, and that is complete. And let's move to PC number 9. Number 9 will have 172.16.224.1, and the subnet mask is going to be 255.255.240.0, and the gateway is going to be 172.16.239.254. Nine is complete. Let's move into PC10. PC10 will have 172.16.224.2. The subnet mask is 255.255.240.0, and the default gateway is 172.16.239.254. And then we are going to tackle the final department, which is the distribution department. And PC11 will have 172.168.192.1. The subnet mask is 255.255.224.0. And then 172, the default gateway would be 172.16.223.254. Close this, you go back to the CLI, you issue ipconfig, and then finally PC12 will have 172.16.192.2, and the subnet mask is 255.255.224.0, and the default gateway is 172.16.223.254. Now is the time to move to step number 11, where we are going to do connectivity verifications. So I'm going to start with PC1. And first things first, I'm going to copy the default gateway, and I try to ping the default gateway first. And you can see that the ping is successful. I try to ping 8.8.8.8. That is also successful. I'm going to do the same with PC3. Ping that default gateway. And we have successful connectivity for PC3. And also I will ping 8.8.8.8. And that is successful as well. Let's move to PC5. Ping the default gateway first. We have a successful ping. And let's ping 8.8.8.8. That is also successful. Let's move into PC7. Copy the default gateway and ping it. We have successful ping. Let's ping 8.8.8.8. Good. Let's move into PC9. And we're going to say ping 172.16.239.254, and we have successful ping as well. And let's ping 8.8.8.8. We also have successful ping. And then finally, I'm going to ping from PC11 to the default gateway, and that is also successful. So let's ping 8.8.8.8. And that is successful as well. What I want to do next, I want to ping from the engineering department using PC2 to another department, for instance, and let's pick the IT department. Let's ping PC5 from the IT department, and that is going to be ping 172.16.248.1. You can see that we have successful ping. And I will do another test, and let's test from human resources to the distribution department, let's say. So I'm going to say ping PC12, which is 172.16.192.2. And we have successful ping. The first request timed out due to ARP. If I repeat this again, we get successful ping 100%. So at this point, once we are happy with the configuration, I can go back to my device and I can save the configuration for my switch as well as my router. So that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. Stay curious, stay inspired, and until next time, peace.